Alright. So, good evening, Professor. Still using mobile phone today. No issue, Faraz. Okay, right. So we have done with all the LSA type, guys. We have done with LSA 1, LSA 2, LSA 3, LSA 4, LSA 5, LSA 6, and LSA 7. And we have also seen the concept of the stub area. We have also seen the concept of totally stub and the NSSA and totally NSSA, right? So these are basically called as a special type of area. Now, the next point is that we are talk about, it's like a virtual link. So before I'm going to start, let me open my lab. Okay, don't I have virtual link? ospf virtual link I have. So another important topic of the ospf routing protocol, the concept of the virtual link. So basically the need of virtual link is what? Try to understand. Okay, it's little bulky. Let me check my small ospf lab for this one. I think so that was on the better. so so the need of virtual link is what? Try to understand. So we have a router number 1, right? And we have router number 2 right now, and we have router 3, right? Okay. So basically between this guy to this guy, what we are gonna do, we'll run the area 0 over there, and this might 12.1 and this might 12.2, right? And then we have a 23.2 and this is 23.3. So between this guy to this guy, I'm gonna run the area number 1, right? So obviously this router will become like a ABR router, right? And ABR has a responsibility to generate the LSA3, or we can call as a ABR has a responsibility to generate the OIA route. Then after that, what happened? We have another router over there, router number 4, right? This router 4 has IP address between this guy to this guy 34.3 and 34.4, right? So now this guy is running with the area number 1, not area number 1, area number 2 over there. So try to understand what is the condition to become the ABR. The condition to become the ABR is what? At least one of the interface will be participate into the area 0. But if you see right now that we have a 0/0 and we have a 0/1, this router 3 is not an ABR because this 0/0 is a part of the area number 1. This 0/1 is a part of the area number 2. So router 3 cannot become the ABR. So if the router 3 cannot become the ABR, what happened in that case? Try to understand. We have a one network behind this guy, 1.0.0/8, right? The router 1 is going to share this information to router number 2, 1.0.0/8 information. Router 2 will have it as an O route, right? As an O route, the next hop will be what? So you will have a 110 will be 80, the matrix will be 1, understand the concept, and the 12.1 will be the next hop, right? Same thing, what happened, router 2 is going to share this information to router 3. So on the router number 3 routing table, what you will have a OIA 1.0.0.0. Then we have 1.1.10 matrix and matrix will be 2. The next hop will be 23 to 2 now. So next hop had changed, right? Previously the 12.1 and now the 23.2. But what do you think? Will the router 3 will advertise this route to the router 4? It will never advertise the route. So you will have a route on the router number 2. You will have a route on the router number 3. So on the router number 2 routing table, you will have a route. On the router 3 routing table, you will have a route, but not on the router 4. The reason is very simple, because router 3 is not an ABR router. Only the ABR router has a responsibility to provide the communication between the two different areas. So router 2 is the ABR because one interface is the part of the area 0, and another interface is the part of the area number 1. So he's the ABR router. How about this guy? R3. R3 is not ABR. R3, this interface is the part of the area number 1. This interface is the part of the area number 2. So R3 cannot become an ABR router. So if the R3 cannot become the ABR router, then what happened? Will R4 will receive the route? No. They will form the neighborship, right? R3 and R4 will form the neighborship, but R4 will never receive the route 1.0.0. So if the R4 will not have a route, the user sitting behind the R4 cannot send the traffic to the 1.1.1. They cannot do that. Whatever the user sitting behind the router 3, they can send the traffic to the 1.1.1. Whatever the user sitting behind the router number 2, they can send the traffic to the 1.1.1. But this guy cannot send the traffic because this guy doesn't have a route. Why this router 4 doesn't have it out? Because R3 is not an ABR. Between the areas, right? If you see, we have two different areas right now. Between the areas, what happened? Only the ABR router can exchange the route. R3 is the ABR? No, there is no ABR on the R3. So to avoid this problem, what you can do that, you have one solution is what? You need to connect the one physical cable. Take a one physical cable from here to here, right? And connect this guy into the area number 0. The physical cable. Now tell me, is it possible that you can put the physical cable from here to here? Okay, take example. If you have a one area, you can put it in. But take example, how many size of area we have? It's a 32-bit range. The size of area is a 32-bit, right? So take example, if you have 100 plus areas in your network, is it possible that all the 100 plus area has a physical connectivity with the area 0? No. So in that case, to avoid the physical connection, what we have introduced, we have introduced the logical connection. And that logical connection, right? That logical connection is known as a ospf virtual link. With the help of this technology, right? With the help of this technology, what happened? I will create the logical link between the router number 2, right, to router 3. So once I'm going to make a virtual link between router 2 and router 3, then what happened? This virtual link is a part of the area number 0. But this is the logical link we have over there. And this logical link is a point-to-point link. So of course, if you have a point-to-point network, this is the point-to-point link we have. Then what happened? We don't have a concept of the DR and BDR. So there will be no DR and BDR over there. So the logical link that I'm going to create between the router 2 and router 3, this will be a part of the area number 0. And this is the point-to-point link. So where you don't have any concept of DR and BDR on the virtual link. So obviously, if I'm going to make a logical link between the router 2 and router 3, then what happened? Router 3 immediately will become the ABR router. Now the router 3 will become the ABR router. Now he can share the 1.0.0.0 information to the router number 4. Now the router 4 can send the traffic to the 101 network after creating the virtual link. So you have to create the virtual link. This is the logical link. This logical link is a part of the area number 0. So then what happened? Router 3 will become a ABR router. And now R3 can share the information to the router 4 1.0.0 information. Have a look. It's a very simple configuration you have. So have a look this topology we have. Let me increase the size. I'll make this as a let me make a font as little big. Yeah, that's perfect. All good. So 1 minute. Okay. All right. So you can see that this is the area 0 we have, right? So there's no ABR right now. Leave it this guy. And let's start the configuration. So already you can see that we have IP addresses 12.1, 12.2, 23.2, and 23.3, and 34.3 and 34.4. That's IP address we have. And then R4 we have a 45.4 and 45.5, and the R5 we have a 56.5 and 56.6. So let me start my configuration. I have a one network behind the router number 1. Just to make a simplicity, I just have a one network 1.0.0/8. And that you can see that 1.1.1 is the router ID of router 1, 2.2.2 is the router ID of router 2, and 3.3.3 is the router ID of router 3, and so on. Okay. All done. All the router is up right now. So let me remove the R4. I already have R1, R2, R3, R4. So let's have a look right now on the router one. So IP interface brief. I must have IP address on this router. And of course, I don't have any protocol enabled. Protocol summary. I don't have any protocol. Same thing if you go on the router number 2 right now. Router 2 show IP interface brief. I have a 12.2 and 23.2. And show IP protocol summary. I don't have any protocol enabled. Let's have a look at R3 now. Show IP interface brief. I have a interface configuration. But if you check the protocol summary, I don't have any protocol of there. Okay, I have. No issue. I'll remove it. Let's have a look on the router 4 now. Show IP interface brief and show IP protocol summary. I don't have it. On router 5 as well. Show IP interface brief. Show IP protocol summary. I don't have. And let's go in the last router 6 we have. Show IP interface brief and show IP protocol summary. All perfect. So now what I can do that I'll go on configuration router number 1. Let me open my notepad. So router 1, we have a router ospf number 1. I see the router ID manually configure 1.1.1.1 and network I see the turn on 160 or 12 or 0. And here we go. Area 0. That's known as a backbone area 1.1.1.1. Or make it 1.0.0/8 we have. Let me check the loopback information. It's perfect. It's /8. Same thing on the router number 2 now. On the router number 2, we just need to configure the router ospf, change the router ID. And I need to change the network for this guy as well. 23.0. And this guy go with the area number 1. Same one on R3 now. On R3, we have a 3.3.3.3. If you see, I just advertised this loopback on the router number 1. I'm not advertising any other loopback on the routers. All done. So this guy go with the 34.0. So this is the configuration for the router 3 right now. How about the router 4? The router 4, we have a same one. It's 4040404. This guy go with the 34.0. This should be go with the area number 1. This will go the area number 2, which is 45.0. So on the router 4, if you see, I have a one network which is running with the 34.0. Another network we have a 45.0. And then we have a router 6 now, router 5 now. Router 5 will also have a router ID will be 55555. This guy go with the area number 2, which is 45.0. And this guy go with the 56.0, which is the area number 2. Sorry, area 3. My bad. And now we have router 6 as a final router we have. I call this guy 6.6.6.6. And I just have one network right now. So I'll configure this guy as area number 3. All done. So now let's put the configuration of router number 1. Copy and paste it. On router 2 as well. On router 3 as well. How about the router 4 now? Router 5. Router 6. All done. So if you check on the router number 1, router 1 is forming the neighborship with the router 2. So you will have this information on the router number 2 as a O route. So if you check on the router number 2 right now, you will have this information as a O route, do show IP route ospf. I have a one-on-one network, right? As a O. Same thing, R2 is my ABR router. If you just have a look, because I have a two interface. If you see the do show IP ospf interface brief, I have a one interface is enabled in the area 0. Another interface is enabled in the area number 1. So if you put the command do show IP protocol, you will see that this is the ABR router. All good. R3 should receive this information, do show IP route ospf, as a 101 as a OIA route. So whatever the user setting on the R3, they can send the traffic. If I'm going to ping this guy, I can. But how about the router number 4 right now? This will receive as a OIA route. This will receive as a O route. Router 4, this interface 0/0 also part of the area number 1, right? So this guy, router 4 also should receive the route as a OIA, right? The reason is that because they all are part of the same area right now. Because in this area number 1, I have router 4, router 3, and router 2. And in this area number 1, we have ABR as well. So ABR can send the route into the area number 1. Understand this way, ABR will send the route into the area number 1. So in the area number 1, whatever the routers are present, all they should receive the route. Okay? Now, how about the router 5? R4, if you see the R4 rule, do show IP protocol. I don't see any ABR on the router 4 right now. So if the router 4 is not an ABR, will they advertise the route? No, they won't. I need to make this guy as an ABR too, right? Can I enable the one loop back over there, loop back number 2, and enable the ospf area 0 over there? You cannot do that. Because in the entire network, you will have only one area 0. You cannot have a multiple area 0. Because the area 0 is used to prevent the loop. If you're going to create the multiple area 0, then route will be not exchanged properly. You will have a loop in your network. So what you can do that, I just need to create the virtual link between this guy to this guy, between ABR, right, to the non-ABR router. So you may have a question, hey, Law, can I create the virtual link between this guy to this guy? No, you cannot do that because this is the border router and this is the border router, because this interface is the part of the area number 1. This interface is the part of the area number 2. So on the border router, you're going to create the virtual link. So this is the border router. R2 is the border router and R4 is also border router. So you have to create the virtual link between this guy to this guy. Once I'm going to create the virtual link, that's called a VL0. This is the identifier. 0 is the identifier, the virtual link. Then R4 will become an ABR router. How you create the virtual link? You just need to go on the router number 2 and see that. Hey, router ospf number 1 through the area number 1, because through the area number 1, I'm going to create the virtual link with whom? I'm going to create the virtual link with 4040404. On router 4, same command you need to say that router ospf number 1 through the area number 1. I'm going to create the virtual link. This is the logical path with the 2.2.2. That's all. All done. All done. So previously R4 was not an ABR and R5 was not receiving the route, right? Now you can see that R4 will be an ABR router, do show IP protocol. It's a border router now. Previously it was not there. We have a virtual link. You can see that. It's up. Now R5 will receive the route because now he's a ABR router. Now he's a ABR router. He can receive the R5 can receive the route as a OIA. So now R5 can send the traffic to the 101.101. So till this point, we have received the route. But how about the router 6 now? If you see, R4 is sending the route to the area number 2. So whatever the routers are present in the area number 2, they will receive the route. How about the router 3, area number 3 right now? R5 is not an ABR router now. R5 is not an ABR router. If you check on the router 5, I'm not an ABR. So if I'm not an ABR, can I provide the communication between the two different areas? No. If you see the router 6, am I receiving the route from the ospf protocol right now? No. So what you can do that, you need to create the another virtual link between this guy to this guy now. Again, border router to border router. This is called as a VL1 now. Why? Because the VL0 is already created. I'll call this guy the VL1. So same command. I just need to go on the router number 5 now. I'm so sorry. And here I need to say through the area number 2, I'm going to create the virtual link between this guy to this guy. On router 4 as well. Through the area number 2, I'm going to create the virtual link between R4 to R5. That's all. So because we are part of the area number 2, that's why I'm saying through the area number 2, I'm creating the virtual link. So now just go on the route of 5. Previously, R6 was not receiving the route, right? Now let's create the virtual link. All done. And have a look on the router 2 as router 4 as well. Not router 4, router on which router are you? Yeah, router 4. All done. So now you can see, right, on the router number 6, you will receive the route. Hello. So now you can see that I'm able to receive the router 1 So now the router 5 is also behave like a ABR router. So you have to create the virtual link between the all the router. Now R6 can send the traffic to 101. That's how the things are. So virtual link is always, remember. So you can see that on R4 you have a 2 virtual link. So IP of neighbor. The priority is 0 for this guy, right? VL0 and VL1. So there will be no DR and BDR for this guy. Even if you're going to put the command show IP also virtual link, you can see that. So VL0 we have with the 2.2.2. R4 is forming the navigation with the 2.2.2. That's a what? It's a point to point. Forget this thing right now. It's not a part of NP. You will not understand it. Once you come to the CCI level, then you will understand the meaning of demand circuit and do not LSA allowed. So even if you see, we have another virtual link with the 5.5. So R4 also have a virtual link with the 5.5. So this is the how you can create the virtual link and exchange the route. Remember one thing, as per the design perspective. Virtual link is a temporary solution. Right? It's not a permanent solution. Like if you want to exchange the route, you can do that just for the temporary, not for the permanent. All good, guys. Anyone has a questions? Okay, I'm take a silent as a no. Let's do the same thing. I'll show you how to change the hold on time and hello time as well. a simple lab. So let's go in the router 1 and router 2. I can show you that, how you can change the hello time and hold on time as well. So under the interface, make sure that your hello time and hold on time must be seen on the both the router, otherwise they won't form the neighbor shift. So IP OSPF hello interval, and I can say that this is the 10 second is a by default, I can make a 2 second, and IP OSPF dead interval will be it's a 6 second. Same command I need to put on the router number 2 as well, otherwise they won't form the neighbor shift. 2 second, and IP OSPF dead interval will be 6 second. Remember what I told you, that if you're going to change the dead time, your weight will be automatically changed, right? Again, don't change the time in the production network until unless you don't have a requirement. Okay, it's never recommendation to change the timers. Yeah, at the NANP level, you know the commands, these things, right? But when you go for the architect level or CCI level, it's never recommendation to change the timer until or unless you don't have a proper requirement. Because if you're going to change the time on the two routers and another routers, if you're not going to change the time, then what happens? You will have a loop in your network. That's called as a micro loop. Very advanced topic. That's called as a micro loop. So if you, for example, if you're going to change the time on this router for the 2 second and 6 second, 2 and 6, and this router I've changed the, for example, 10 and 40, which is by default. And if this guy go with the 10 and 40 again, 10 and 40, and this guy somehow is got the 5 and 15, and this guy got the 5 and 15, but this guy's got the 2 and 6 and 2 and 6. So if you see, we have a different timers in the network, right? Then you have a loop in the network, because this will be converts fast, this will go slow, this will be go slow, this will converge fast, and this will also converge fast. So you will have a macro loop in the network. So never recommendation. But if you have a requirement, if you have all the approvals and everything, then you can go and change the time. So now if you see on the router 1, so IP host neighbor, my neighbor is a very fast. So that time is a 4 only RAM. Can you see 654, right? So you will not go for the 40 second now. And if you check the show IP host interface, what we call, if you see the, I change my hello time and dead time, my weight has automatically changed over there. Retransmit time is what? So if some, because ospf is a reliable protocol, right? So the router 1 is there and router 2 is there. So if I'm sending the LSU packet, link state update packet, and somehow if I'm not getting the acknowledgement, then what happened? I will do the retransmission again after the 5 second. Again after the 5 second, I will do the retransmit until I haven't received until I haven't received the acknowledgement from my neighbor. So that's our meaning of retransmission. So this is all over the timer. Same thing, you can also set the password. So in a OSPF protocol, we have a 3 types of password. That's called the null zero, null password. The code is 0. It means that no authentication. No authentication. Then second type of authentication, we have a text authentication. That's called the code number 1. And then we have a MD5 over there, the code number 2. Right? How you can apply it? Simple way. You just need to go on the router number 1. So on the router number 1, I can see that interface 0/0 IP OSPF authentication, and IP OSPF authentication key will be CCA. Same thing on the router number 2 now, because they drop the neighborship, so there's no neighborship now. I need to apply the configuration on the same time. IP OSPF authentication, IP OSPF authentication key will be CCA. So this is the way that you can apply the clear text authentication. easier, right? So already we have discussed the meaning of authentication. So no need to discuss the same thing again and again. But if you have a question, you can feel free to ask me. So that's how you can apply the text authentication. We can call it the clear text authentication, right? So the problem with the clear text authentication is what? If there is a attacker in between, they can sniff your data. They can sniff your packet and they can see the password. Not they can see your password. So if you see the hello packet, so in the hello packet, they can see your password. So if you can see the authentication data, we have a CCI and the code is 1 over there. So by default, let's go with the null or the code is 0. The opcode value, we can call it, right? The password we have set the CCI. That's a problem with the clear text. So what I can do that, I'll simply gonna apply the authentication as a MD5. So here I have did the text authentication. Here I can do the MD5 over there between the Arju and Option. So how you can do that? Interface 1/0 IP ospf authentication. Sorry, I got a call. IP ospf authentication. Then you have a message address. IP ospf authentication. Key will be CCI one SIM1. That's fine. And R3 as well. What is R3? R3 this interface. Otherwise, they will drop the new ship. Interface 0/0. IP ospf authentication. Message address. IP ospf authentication. Key will be CCI. So this is how you can apply the MD5. All done. So now you can see that if you want to snip this packet, you will have a password, but this password is secure. So this is the secure way. So you cannot read the password, right? So if you see the clear text one, that you can simply read the password. The password is CCI, but you cannot read. So this is the cryptographic. So we have opcode 2 over there. This is the opcode. So that's how you can apply the authentication, guys. And that's how you can change the interval as well. One few things more. So about the virtual link that I want to discuss. So virtual link is known as a transit area as well, right? Virtual link is known as a transit area. So in a transit area, this is the interview question. In the transit area, you cannot do the stop. So I cannot configure the area number 2 as a stop because we have a virtual link between this guy to this guy. So if you're going to configure the area as a stop, let's go on the router 4 and see that area number 2 as a stop, it will throw the error message. Because it's a virtual link. A virtual link is known as a transit link. A transit link, a transit area cannot be configured as a stop. Area 0 is also known as a transit area, and virtual link is also known as a transit area. So under the transit area, you cannot configure as a stop. So virtual link is also known as a transit area, and area 0 also known as a transit area. So on the transit area, you cannot configure as a stop over there. Right? Now, the topics that's also important, summarization and filtering. Let me stop this guy. I need to go with the different lab. LSA3 filtering. Okay, right. So that's a lab I have. So if I talk about the filtering perspective in the ospf protocol, right? So in a EIGRP protocol, if you remember that, you did the filtering, right? In a EIGRP protocol. In EIGRP, we did the filtering. That filtering is known as a Radd filter. But in ospf protocol, we do filtering, but this is known as a LSA filtering. So we are not doing the Radd filtering. Of course, if your LSA will be now, please can you set the multiple authentication of those? Multiple authentication in the sense of what? I didn't understand your multiple authentication. Set the multiple authentication question. So what you can do that, you can do the LSA filtering. So obviously, right? So the first of all, a route comes over there in the routing table, right? 1.0.0.0, and then we have a LSA database LSDB over there. So basically what we are doing that in the route filtering, basically what happened, you are filter the route from the routing table, right? In the LSA filtering, what happened, you are going to filter the LSAs over there. So obviously, right, because after we are running the SPF algorithm on the LSDB table, then you are going to push this information in the routing table. So if you're going to filter the LSDB, of course, you will filter the route as well. So in a ospf, what happened, you are doing the LSA filtering, not the route filtering. So take example, if you do the route filtering, then what happened? If I'm going to filter the route, then route will be not there in the routing table, but LSA still will be there. So that's not a good way, right? Because in that case, what happened? You will not able to forward the packet, but the problem is what? You will still gonna maintain the information in the LSDB table. That's consume the CPU and memory. So better to do what? Filter the LSCs over there in the OSPF protocol. But in the case of EAGRP and BGP, even in the RIP protocol, we are doing the route filtering because we don't have LSCs over there. But in the case of OSPF, we are filtering the LSCs. So which LSA you can filter? You can filter the LSA3 information and you can filter the LSA5 information. So simply LSA3 you can filter on the ABR order and LSA5 you can filter on the ASBR order. The reason is very simple, right? Because LSA3 is generated by the ABR order and LSA5 is generated by the ASBR order. Commands are different, but same funda filtering, right? Remove the unwanted information from the routing table that we did in the EHGRP protocol. So let me put this guy in the top. Hey, Nee, I didn't understand your question. Can you please explain that one so that I can understand the multiple set of authentication? All done. Out of 5 we have. All good. So I'll take this guy a little bit over here. Let me remove the out of 5 and out of 1 we have. So I already have a OSPF configuration. What I can do that, I'll simply gonna remove this guy. I don't know why it's not working. Right, so I'm gonna remove the guys. Please be on mute. Someone mic is always on. I see that. I have to always mute. So of course, if you have a question, you can unmute yourself. But please, show IP interface brief. And I have a 12.1 and 101 11.1 as well, right? And now what I can do that, show IP protocol summary. If you see, I do have a ospf enabled. So I'm simply gonna remove that because I'll want to show you the scratch. Show IP interface brief now. I have a 12.2 on the router number 2, 23.2, 24.2, and 25.2. So we have a four different interfaces, right? So of course, router 2 will behave like an ABR router, right? Because it's connecting the multiple area right now. I'm going to remove the host from there. R3 as well. I have already configurations, right? IP configuration. I'm just going to remove the host now. R4, we have show IP interface brief. I have IP. I'm just going to remove the host now. R5 now, show IP interface brief. And I'm going to remove the host now. All done, right? So we did the ospf part. Sorry, we did remove the ospf part. Let's do the ospf configuration. So I can open my notepad and
Yeah, it's true.
Hazar, you are on, please be on mute. So we have router number 1. And as the router ospf. So this is called as a filtering. LSA is filtering. Guys, we have already done the what is meaning of filtering or why do we need a filter, right? In the EHRP protocol. So if you have a question, you can ask me, otherwise that's fine. So network, I'll have a 12.0. Let me do the router ID for this guy. So the router ID will be 101.101 and so the network 12.0. And here we go. And on router 1, I have a loop back as well. So that's a 1, area 0. I can configure in this way as well, right? And 11.0.0.0 we have area 0. Router 2 I have router ospf number 1. Can we set the different password on the F0/0? Can we set the different password on the F0? Yeah, of course you can do that. There will be no pay because the password will be sent between the, so understand this concept. So we have router 1 over there, we have router 2 over there, and router 3 over this side. So you are showing, your question is saying that 0/0 and 0/1 we have. So I can set the password CCI over there. I can set the password CCNA over there, right? Because I'm going to send the hello packet on this particular interface. I'm going to send the hello packet on this particular interface. But make sure that this side should be CCI and this side should be CCNA. Now you got that?
Yeah, sure. Thanks.
Great. Thanks. So all done. So on the router 2, we have router OS number 1 as the router ID will be 2.2.2.2.2. Network I have which one? 12.0 should be part of the area 0. And I have another network which is 24.0 if you see that, which is the part of the area number 4 right now. Network we have 23.0, which is the part of the area number 3 right now. Network I have a 25.0, which is the part of the different area now, again area 5. So of course, router 2 will become the ABR router. Router ospf number 1, router ID will be 3.3.3.3.3. Network we have what? R3 will have a 23.0. Area 3 now. Router 4 we have router ospf number 1. Router ID will be 4.4.4.4. And network we have a 34.0. No, 24.0. Area number what? 4, right? And out of 5 we have now network we have 25.0. Done, right? So let's put this configuration on the all the router. All done on the router 1. Router 2 we have. Router 3 now. Router 4. Looks like Bangalore is enjoying lots of crackers. Router 5. All done, right? So we have done with the configuration of the ospf. Now you can see one thing. Let's wait for some time because R2 is going to form the neighborhood with every question. So DRVDR is going on. The waiting state. All done. So we did form the neighborhood, the R1, R3, and R4. We are waiting for the R5. All done. So if you check on the all the router, if you check on the router 4 right now, do show IP root ospf, I should receive the 1 and 11, right? Even if you check on the router 3 right now, do show IP root ospf, I should receive the 1 and 11 as a OI route. Even if you check on the router 5, you should receive the 1 and 11. Even if you check the data was stable, so IP was for data was stable, I should receive the LSA 3, right? Which is advertised by the 2.2.2.2, the ABR router. Same thing, even if you check the router 4, data was stable. This guy, right? Advertised by the 2.2.2. So focus on the this 2.1. And same thing on the router 3 as well. I have a 101, which is advertised by the 2.2.2. What I can do that, I'm gonna filter out. What I'm gonna filter out, I should not see this 1.0.0/8 in the area number 4. I just want to have only the 11.0.0.0. That's all. I want to filter out this guy. 101. So what you can do that, you just need to go on the router number 2 route, because router number 2 is a AVR router. So you have to do the LSA3 filtering on the AVR router. For the condition of the LSA3 filtering is what? There should be prefix list, right? Because you need to match this guy first of all. So IP prefix list. So you cannot do based on the ACL on the iOS router. Okay. So IP prefix list CCI as the deny, which I'm going to deny. It's a /32. IP prefix list. I'm going to format everyone. Less than 32, right? This is the command that we have done in EIGRP2. And now a router ospf, why can I say that? I'm seeing under the area number 4. Under the area number 4, I'm going to apply the filter list. And in this filter list, I'm going to call the CCI in one direction. That's all. So what I'm saying that I just say, hey, whatever the route that is coming in the area number 4, hold on, check the filter list. The filter listing the CCI. Under the CCI, I have denied the 101. So I'm going to block the 101 over there. And I'm going to allow the 11 only. So let's do on the route 2. Okay, why throw the error message? I missed that prefix of the keyword. That's a prefix listing. Right? So now I can check on the router 4. The first thing you need to see is LSA3 filtering. So you will not see this LSA now. Hold on. So you are saying, okay, now it's gone, right? It's not there. One is gone. So even if you check the routing table, so of course, if you don't have a in a LSDB table, you will also not have in the routing table as well. I don't have. So that's how you can do the filtering for the one area. But take example, if you want to filter out for the all area, because right now R4 doesn't have, or we can say the area number 4 doesn't have a 101, but R3 still have, right? Can you see? R3 still have. Even R5 still have. That's the area number 5. So take example, I want to filter out from all the area. So first remove this configuration. What I can do that? I'm going to remove this guy. Right? So now I'm going to filter out for all the area. Same configuration. Prefix will be called. Now what I can see that, hey, listen, don't advertise the 1.1.1 to the any guy. So all the routers should only maintain the 11.11. Should not maintain the 1.1.1. So in that case, what you can do that, I just need to call, hey, whatever the LSAs that are coming from the area number 0. I understood the concept. So I'm sitting on the router number 2 right now. I'm saying that, hey, whatever the LSA is coming from the area number 0, apply the filter list. The name of filter list is was CCI that we have. And instead of doing the in, I'll say the out over there now. So I'm not going to send it. Out means I'm not going to advertise it. So this guy is sitting on the router number 2. He's not going to send it out to the any guy. So I'm just going to switch the out direction. Copy. So already the prefix list is there. I just need to copy this person. That's all. Because prefix list is already present, right? I just need to call this guy. That's done. So now you can check. So of course, R4 should not have. So you can see the show IP root ospf. I don't have a 101. And even if you check the database table, I don't have a 101. Okay, hold on. It will remove. Already it's gone, man, because it's a 3600 second. So if you check the routing table, you will not have. Right? It's not there. Even if you check the router 3 right now, it's gone, right? And even if you check the routing table as well for this guy, R3, you will not have. Same thing on the R5 as well. You will not have a 101. So this is the way that you can filter the LSA3 information. So either you can do the in direction for the specific area. Out direction is what? For all the area. Perfect, right? This is how you can do the filtering for the LSA3. Same thing, you can do the filtering for the LSA5 as well. I'll show you that you cannot, because I have to go with the next project. So let me check. Remember one thing, within the area, you cannot do the filtering. So you cannot do the filtering of the LSA1 and LSA2. You cannot do that. So take example, all this router we have, router 1 and router 2 and router 3. So 1.1.1.1 we have on the router number 1. You cannot do the filtering within the area. Right? Always you are doing the filtering for the LSA3 and LSA5. Within the area, you cannot do the filtering because within the area, you don't have LSA3. You only have a LSA1 and LSA2. And the requirement of the link state database is what? The link state protocol is saying that, hey, all the router within the area must have a identical information. All the router within the area must have a identical information. So within the area, you cannot do the filtering. That's a behavior of the link state routing protocol. Between the area, you always do the filtering, like LSA3 and LSA5. So let me check. Okay, no. I see the ospf. Let's say 3 we have. LSA 4, LSA 5. I don't have filtering for the LSA. Man. Okay, I'll do the yesterday lab. So I'll remove the EHRT from there. I don't need it. All done. So let me turn on the routers. So already we did this lab yesterday, if you remember that. So same IP configuration is there, right? I'll just gonna show you the how you can do the LSA 5 filtering. So we have all these route, which is seen as the LSA 5 on the area number 1 and area number 0. So where you can do the filtering for this guy, you're gonna do the filtering on the ASVR router. Right, so let me check. I think so IP is already set, but let me verify this thing. Oh, perfect. I have IP configuration. So, but I must not have any OSPF over there, right? So let's configure the OSPF. So all good. So I have a router OSPF one and perfect, right? On router one as well, I just need to configure the DIP protocol as well. Router two, router OSPF number one, router ID will be area number one. I have right R3. All good. Area number one. Have a 34.0 as well. That's also part of the area number one. R4 now. R4 we have a same lab that we did yesterday, man. Nothing is different. R3, R4. Here we go. R5 now. R5 is a RIP protocol, of course. When I was learning the CCNA and CCNP, I love the RIP protocol. It's very easy to configure it. Even the troubleshoot for this guy is very easy. No auto summary. All done, right? So we do go in the router one, just configure the router ID manually of this guy. Okay. Cisco CLI is something like that, हाँ बेटा तू गलती कर मैं मारता हूँ तुझे थप्पड़. So you have to be very careful with the spelling. Right on the R2, right? Hey, I have must have IP configuration. Come on. Yep. Okay, please. I throwing a message on this. Turn off on dot. R3 or bingo R4. All done 34 or 4 and 4 or 4. Look back. And R5. That's my rip configuration. All done. And let me save this one. This is the one of 5, right? All done. So what we have to do on the router 1? Router 1, we need to do the registration, right? So that R1 can advertise the LSA5 information. So RIP will be converted into the LSA5. Redistribute RIP protocol, include the subnet keyword for the classless router. Under the router RIP, ospf, matrix, move it to. Perfect, right? So now you can see, check on the router 4 right now. Router 4 will have a bunch of LSA5, not a bunch of course, only 4. Wait for some time. Mistake, right? IP. So it was 15.1 configure, right? It should be 1.1 according to the diagram. So now check on the router 1 again. I received these network on router 1. So now the router 1 can advertise as a LSA5 to the router 4. All good, right? So let's block it. Which one I'm going to block? I'm going to block the 5.0.0. How you can block? Simple configuration like a EIGRP we did it. The concept of the distributed list. So access list. So you have an option in the LSA5 filtering. You can choose the ACL or prefix list. But in the case of LSA3, you don't have an option. You have to go with the prefix list only. Access list 1 deny. I can say the 5555. Wildcard mask access list, I'm going to remaining allow it. Router OS script number 1. On which router we are doing that? All this doing on the router ASP router. Router 1. Distribute list 1 out direction. All done. So now I can check on the router 5, sorry, router 4. You will not have this information. So advertising router is 101.1, 101.0 ASB router. It's okay, still there. Hold on. Why is there? Oh, it's a /8 router, guys. I have configured the as a /16. That's why it's there. That's all right. Remove the ASL back and put it back again. Now that's fine. It's gone, right? We don't have 5. So even if you check the routing table, in a routing table also you don't have a 5 network. I don't have 5. I have a 55, right? I have a 170.16.0. I have a 1.0, but I don't have a 5 network. So this is how you can do the LSA 5 filtering. One thing, let's finish it. Okay, the summarization. So how you can do the summarization for the same one? For the LSA 3, you can do on the ABR order. For the LSA 5, you can do on the HBR. So already we did the summarization in the HRP as well, right? What is the use of summarization? To just reduce the size of routing table, right? And improve the router performance. So in that way, what happened, you can save the lots of CPU and some lots of memory, right? So let's do that. So let me do one thing. Let me advertise all this network, 1, 2, 3, and 4. I have it or not. Let me check my interface configuration first. I don't have, I don't have it. So what I can do that. Okay. So if I'm going to do the comparison, this will be comes in my network for this guy. Okay, let me hang it. What I can do that. So I'll change this guy and figure out which one. Loopback number 2 will be, loopback number 4 will be, loopback number 5 will be, yeah, loopback number 6. Right? So I'll create the loopbacks over there. I'll simply go and enable the ospf 1 area 0. That's fine. Interface loopback number 5 as well. Right? 6. All done, right? So on a router 2, or we can say the 3 router, you can check that. You will receive as a OIA router. Can you see that? 4, 5, 6 OIA router. So you have a bunch of LSA3 right now. OSPF database, you have a bunch of LSA3. 4, 5, 1 advertised by the. Even if you check the routing table side, do show IP route summary. I'm consuming the 3,888 bytes of memory and 728 is the CPU. So what I can do that, I'll just convert this 3 routes into the single one. You just need to go on the ABR order because ABR can do the LSA3 summarization. What you can see that whatever the route that is coming from the area number 0, of course, these are route coming from the area number 0. I will convert into the range, right? What will be the range for this guy will be 4.0, I can call it. And submit pass will be 252. Advertise it. So now check on the route 3 now. It's gone, right? 3,880 bytes to 2,900. So almost 1,000 bytes of memory I have saved. So previously the routing table size of 8, now it's 6 only. I have reduced the overhead as well, right? So now I can check the do show IP route as well also. I have a summary route in my routing table. Even if you check the database table right now, do show IP host for database table, I have a single LSA right now. I can send the traffic to the any guy. So you can see I can ping 5.1 as well. I can ping the 6 as well. So this is the how you can do the summarization for the LSA3 simple command. Under the OSPF, you need to convert into the range. Same way, you can do the LSA5 filtering, right? That you can do on the ASP. So I'll create a bunch of loopback over there. So the loopback will be, I'll have add another one. Right? This three loopbacks I'm going to create on the route of 5. So I have a loopback number. Let me check what loopback number I have first of all. I have a loopback number 3, which is the 101. I'll create the loopback number 2 now. Now loopback number 4, which is the 2.1. I'll get another loopback number 5, which is the 3.1. All done. Simple. Router depth protocol version 2 network 2.0 and network 3.0. I was already advertised the one network, if you see that. So no need to advertise the one again. So now you can check on the router number 1. You must receive this route as a REP protocol on router 1. And router 1 will advertise as a LSA5 to the R3 and R4 as well. Even on the R2 as well, right? So you can check on the router 4. You will see as a LSA5 E2 route. Right? So what you can do that, you just need to go on the router number 1 and just say that router ospf number 1 summary address, because you have to do on the ASB router. So summary address will be what? 172.16.0.0. I'll call this guy into the one submit. Advertisement. So if you just say that no advertise, then what happened? Without ACL, I can do the filtering. So now I can check on the router 4. You will see only one now. So all the LSA5 has filter now. All this 3.1 is now going to convert it, not filter, all this 3.1 is going to convert it in the 1. I can send the traffic to the all this network. So this is how you can do the filtering for the LSA5. Also the one Jadu. So what is the AD of the OSPF protocol? 1110, right? Every word is written over the 1110, right? See the AD for the summary dot for the LSA5. All right. So if you do the summarization for the LSA5, the AD will be 255. That's only for the loop prevention, nothing else. Don't say anybody. The AD has a 254 as well for the OSPF. It's most of the person has no idea. Yeah, we have a 254 AD for the OSPF as well when you do the summation. So remember now you have a 2 AD. One is a 1110, which is reserved. 254 when you do the summation. Right? So that's how you can do the summation. If you know convert, like right now you can see that these are the route, R4 as a E2 route. You see that it's a E2 route. If you convert in the E1, you can also do that. You just need to go in the router 1. So this command was there, register RIP protocol subnets. By default, it will do the E2. You can convert into the E1. Yeah, type 1. So now all this route you will see as E1. So E2 and E1 already we have discussed yesterday, right? So here is the I'm done with the OSPF protocol, guys. Many things is already we have discussed, like illicit filtering and summarizing concept we have already done. So that's why the burden is only in the EHRV part, not in the OSPF. So even in the BGP, same concept, the filtering, authentication, summarization, same thing. The major part of the BGP is the path attributes. Right. So one topic is pending, that the OSPF states over there. So we'll discuss this OSPF state tomorrow, right? So all the topics has completed of the OSPF protocol. If you have any questions, you can feel free to ask me now. I'll do one thing. I'll put the OSPF state's name. I will discuss this thing on next class, so that this notepad will be the final notepad. I'll save it down. Neat. Not Kabul. Yes. Anyone has a question, guys? No. So I'm taking silent as a no. Okay. So